Hi all there. Before getting into this video, I would like to introduce myself. My name is G. Tilak. I'm working as an assistant professor in Hindustan College of Engineering and Technology in Mechatronics Engineering Department. So before getting into this video, so I would like to tell you the topics which I'm going to discuss. So it is going to be under the subject called strength of materials. I'm going to take a few topics under that. So the topics which I'm going to discuss with you all is about the types of loads. So in this slide, I'm going to talk about the types of loads. So it is well known that the types of loads are very important while designing any structure, any engineering structure for that matter. And we have two types of loads. One is static load, another one is dynamic load. So first of all, we'll discuss about the static load. What is static load? Static load are the forces applied gradually and they remain constant, quite constant throughout uh, the application. So the best example is the dead weight. For example, if you take a building, the dead weight is the floor or the roof system, which is not alive. It remains constant throughout the application. So the next load is the dynamic load. So what is this dynamic load? So it is just opposite to the static load. So where the load actually varies with time, they include repeated and impact loads. So under this dynamic loads, as I said, repeated load and impact load are the classifications. So what is this repeated load? So repeated load, by the name itself, you can understand the load gives you, or it is being applied number of times on a structure, on a body. So if a force is applied a number of times on a body, obviously vibration takes place with variation in magnitude and sometimes also in the internal forces. So for example, off balance motor will give you a good insight of this repeated load. So if there is a motor which is not balanced properly, it experiences wobbling and there's no any concentricity in that thing, the rotating part, concentricity on the rotating part, and as a result, as I said, the wobbling occurs and vibration occurs, and as a result the total system fails. So this is the impact of repeated loads. So the next type of dynamic load is the impact load. So what is this impact load? So the impact loads are the forces that need a structure or a component to absorb the energy in a very short interval of time. So let me give you a simple example for this impact load. There's a heavy weight dropped on a floor or a floor slab. So what happens to that heavy weight, the forces due to that heavy weight? So those forces are getting absorbed by the floor slab. So I can even more give you, make this very clear. For example, if a car is moving at a great speed and unfortunately it goes and bangs on an object, so the force which is given on that particular object by that fast moving car is the impact load. So the object which receives the load from the car, actually it absorbs all the forces from the car within a short interval of time, so that the impact causes more damage to the object on which the car banged. So this is all about impact loads. So we would have addressed this impact loads, by addressing any accidents on the roads. You could see the impact loads damage on that particular object. Yes, I hope you all understood what is impact load. Then coming to the uniformly distributed load. What is this uniformly distributed load? By the name itself we can understand it has been uniformly distributed across the surface area of the supporting member. For example, you could take the beam. So a beam is a structure where it actually subjected to a kind of load which is uniformly distributed. So here is a good example, like dead weight of a rolled steel I-beam. So this is a uniformly distributed load. So coming to the next type of load is a concentrated load. What is this concentrated load? These are the forces having such a small contact area as to be negligible compared with the entire surface area of the supporting member. So what does it mean? So it is concentrated. It is only focusing on a very small area across the supporting member. Okay, so here there's an example. A beam supported on a griddle, for instance, might be considered for all practical purposes a concentrated load on the griddle. So this might give you an idea of for what concentrated load is. So another common classification for external forces, name them axial, eccentric and torsion. So now what is an axial load? An axial load is a force which passes through the center of the section under consideration and is perpendicular. So this is axial load. So the next type of load is an eccentric load, where the forces are perpendicular to the plane under consideration but not passing through the center of the section. So as a result of bending, the supporting member occurs. So let me put this in a simple way. This is a beam which is simply supported on either sides, and this is the center of that particular beam. And if this beam is subjected to an eccentric load like this, so what happens to the beam? So because of this eccentric load, the beam tends to bend. So it tends to bend like this, so which causes failure. So this is a kind of load which actually should be considered while designing a structure. So the next load is torsion loads. So these are the loads which are offset from the shear center of the section under consideration and are inclined to or in the plane of the section. So as a result, the supporting member twists. So the twisting occurs due to this load. So the next load in line is dead loads, which include the load of an equipment, material, construction or other elements of weight supported in, on or by a building, including its own weight. So these weights are always remain permanent in a place and it is not alive. So the next type of load is live loads, which include materials, occupants, equipments, construction, or elements of weight supported in, on, or by the building that are likely to be relocated. So this type of loads are called live loads. So in this slide I'm going to discuss about the effects of the types of loads. So the first effect will be a compression because of compressive force. By looking at this diagram, it is well understood that uh, there are two forces acting in opposite direction, but it is a kind of pushing force. So it is a crushing force. So where it impacts on this cylinder and it changes its dimension linearly and laterally. So what does it mean? So if this is happening on this cylinder, the length of the cylinder gets decreased, whereas the diameter of this cylinder gets increased. So this is how the impact of compressive forces on the object of on any object for that matter. So coming to this tension, so this tension is actually occurs while tensile force is subjected on a body. So what is tensile force? As I said, tensile force is the pulling force. So here again, the dimension of this cylinder changes linearly and laterally in a different manner. So while pulling, the diameter of this cylinder decreases while the length of the cylinder increases. So this is a kind of effect of the tensile force on the cylinder, on this particular object. So not only on this object, for any object for that matter, if tensile force is given, there will be change in its length as well as in its diameter or breadth or something like that. So the next effect is torsion. So this is due to the twisting force on either sides in opposite direction, so that the body gets twisted to some angle, so that torsion occurs. So the fourth one is the bending effect due to eccentric loads. So you can see a cylinder is subjected to eccentric loads and it is supported at its center. So due to these eccentric loads, the bending happens. So coming to this diagram, you have an application where you have a motor and a fan. So the motor is driving the fan. So this is the driven part and this is the driving part, where the motor shaft is connected with the shaft of the fan. So here there is some twisting force happening because this is the rotating member where the energy is transferred from the motor to the shaft of the fan. So as a result, the fan rotates because of the torsion. So in this slide, the tensile load is explained with a diagram, and in this diagram we all can see an object which is subjected to a force P, that is pulling force on either sides, and XX section is taken to represent the resisting force. So what is this resisting force? The resisting force is nothing but the internal force induced by that particular body to oppose the force P, that is the pulling force, and this force will be always equal to P, that is R is equal to P. So the next force here is torsion. So this torsion is explained with an example, and that example is very simple here. You can see the motor is connected with the load, and the whole setup. Suppose if this is an automobile, and a motor is connected with the load. If the whole system is moving downhill, so if it is moving downhill, it is well understood that the load is very less and the torsion is also very less. and the speed of the motor increases and the power flow actually decreases. The effort of the motor actually decreases here and it easily drives the load downhill. Whereas when it comes to uphill movement, the power flow, that is the motor which gives the power, will increase. The power flow will increase. As a result, the torsion also increases because the whole system is moving uphill. So the motor experiences the load and automatically the speed of the motor decreases. So this is a simple example of torsion. In this slide, the compressive load is explained with a diagram. So in this diagram, it is clearly understood that the P is the compressive load which is acting on the slab, and this slab is supported by the columns 1, 2 columns, that is 1 and 1 on either sides, and there's another column 2 which is slightly away from the slab. So as this P increases, as the compressive load is increased, this tends to compress the columns 1 and 1 and it reaches the column 2. So by this experiment, it is clearly understood that by compressive load there will be decrease in length L. So the change in length here will be del L, which is equal to capital L minus small l. So concluding this, it is well understood that a compressive load always decreases the length of the material on which it is subjected. Thank you. So that's the end of this video. Thank you for patient listening, and I hope all got some idea about the types of loads and its impact. Thank you.